we want to look at this particular example, and I guess this is going to be our last example that we are looking at under the method of change of variable. And remember, we are looking at what with variable coefficients. So in doing that, or in solving this particular question, we are going to apply the steps that we used in our earlier lesson. We are going to apply the same step because you can see that we have a first order linear PDE with what variable coefficient. We have the variable here and then we have a constant here. Since we have a variable, we are going to apply the steps for what variable coefficient. So the first step says what we should identify the coefficient of ux and then uy. Then we form the characteristics equation, we solve it, we set the solution to Zaya, and then we continue from there. So let's start without wasting much time. So we have our solution. So we identify our coefficient of us, and that is what x. So we have our a is equal to x, and then our b is equal to coefficient of uy, and that is 1. Once we have this, we form the characteristics equation. So you know that the characteristics equation is giving us dx over a, is giving us dy all over b, and then we have du all over f. So from here, since we are interested in dx and dy, we are going to plug in that. We have our dx all over x is equal to dy all over b. Our b is 1. So once we have this, we integrate if possible, or if we have separated the variable, we can just integrate straight away. So from here, you can see that we've already separated the variable into x and then y. So we can just integrate. So from here, we take the integral on either side of the equal sign. So when we integrate dx over x, we are getting what? Ln x. Remember that with this, we can write it as the integral of 1 over x, and then we have what? Dx. We have a function and a derivative, and it gives us what? Ln of that function. Very, very easy and then simple. So from here, we integrate dy. When we integrate dy, we get what? Y. Then we add our constant of integration. And since we are having ln on this x, we can also decide to take the ln on the constant as well, so that we can clear the ln from the equation. So from here, we can group the ln's together. So we have ln x and then minus ln what? C is equal to what? Y. We can apply our basic knowledge in logarithm. Ln and ln, they are subtracting. We pick one of the ln, we divide their argument. So we have ln x all over what? C is equal to what? Y. Now let's do away with the ln from the equation by taking e on either side of the equal sign. So we have e and that, so that this will cancel over the ln. So at the end, we have what? X over c is equal to e exponent what? Y. We are interested in making what? C, or finding c. So from here, we can multiply both sides of the equation by c, so that this will cancel this. So we have our, let's see, x is equal to c e exponent what? Y. Let's divide both sides by e exponent y, so that this will cancel this. We have our c is equal to what? X e exponent negative y. We can write this in an index form, because when we have x all over e exponent y, we have x, and then applying our indices negative reciprocal, we can write it as e exponent negative y. Very, very easy, and then what? Simple. So we said that when you find the solution, you set the solution to what? To Zaya. So we have our Zaya is equal to what? X e exponent negative y. Since we have our Zaya, then we need to find what? Eta. We can either set eta to x or eta to what? Y. Any one of them is going to work. So what do you suggest we take eta to? So we can set our eta to y. So we set our eta to y. So once we have this, we take the partial derivative of xi with respect to x and then with respect to y. The same thing applies to what eta. So we have xi x. We are differentiating this whole function with respect to what x. So it means that any function of y become a constant. So we have this, then we differentiate x with respect to y, that gives us 1. 1 times this will give us the same 1. Then we differentiate it with respect to what? Y. So we are differentiating xi with respect to y. Any function of x becomes what? A constant. Then we differentiate e exponent negative y with respect to y. So we are going to have, let's do it here, e exponent negative y. We are what? Differentiating. So we have the xi, the y. So we are going to repeat the function negative y, and then we multiply it by the derivative of the exponent with respect to y. That is what? Negative 1. So we have negative e exponent negative y. So this is going to give us negative, let me bring the negative in front, and then e exponent negative y. Now let's move on to eta y. So we are going to take it with respect to x, that's going to give us 0, and then eta with respect to y, that's going to give us what? 1. Good. Now once we have this, we write down the expression for ux and then the expression for what? Uy. So we know that ux is given as what? U xi x plus u eta x, sorry. So we have eta x. And then uy is also given as u xi y plus u eta y. So we are just going to plug in xi x, xi y, eta x, eta y into this equation. So we have ux. So ux, we have u xi x. So this is xi x. So when we plug this in place of xi x, we are going to get what? E exponent negative y u xi. Then we have plus u eta x. Eta x is 0. So when we multiply it by that, we are going to get 0. So we are done with ux. Then we look for what? Uy. So uy, we have u xi y. Where is xi y? This is xi y. So we are going to have negative x e exponent negative y u xi, then plus u eta y. This is eta y. 1 times u eta, we have u eta. Very, very easy. So once we have this, we are going to substitute ux and uy into the equation that was given. So this is the equation that was given. So wherever we see ux, uy, ux we plug in this, uy we plug in that. Very, very easy. So we have our, so we have x, then we have ux. So this is ux. We are going to plug in this. Then we have plus uy. This is uy. I'm going to plug in the whole of this. Minus x e exponent negative y u xi plus u eta is equal to 1. So let's remove the bracket and then see if we can cancel some. This is going to give us x e exponent negative y u xi minus x e exponent negative y u xi plus u eta is equal to 1. So from here, we can see that this is going to cancel this. And then we have our u eta is equal to 1. So from here, we can just integrate it straight away since we have u eta is equal to 1. You know that if you have ux, you can write it as what? Del u del x. Therefore, if you have u eta, you can write it as what? Del u del eta. So we are going to write this as del u del eta is equal to what? 1. Now we can separate it into u and then what? Del eta. So we are going to have del u is equal to what? Del eta. Then from here we can what? Integrate. So when we integrate del u, we are going to get what? U. We are going to get what? U. And then when we integrate del eta, we are going to get what? Eta. Then we add our constant of integration. That is what? C. Since we are looking at what? Xi and then eta, when we are integrating with respect to what? Eta, any function of xi becomes what? A constant. So our constant is going to be a function of what? Xi. So we have a function of what? Xi. So from here, we can say that the general solution, which is in terms of xi and then eta, is equal to eta plus a function of what? Xi. Now I realize that our general solution is in terms of xi and then eta, but the question was given in terms of what? X and y, which are the independent variables. So once we read this variable point, we are going to return our original variables back. Our original variables are what? X and y. So we are going to return it back. How do you return our x and y back? We can return it back using this equation. We said that xi is equal to this, and this is in terms of what? X and y, and then eta is also this, is in terms of what? Y. So wherever we see eta, we can plug in y. Wherever we see xi, we are going to plug in the whole of that. Very, very easy. And then simple. So our general solution, which is going to be in terms of x and y now, eta is what? Y. So we have y plus a function of what? Xi. This is xi. So we have xz exponent negative y. So these are general solution. Our what? General solution. But realize that with the question given, we have an auxiliary condition or initial condition, so we have to proceed to find the particular solution. So we said that ux0 is equal to sine x. This means that from here, our x is equal to x, our y is equal to 0, and then our u is equal to what? Sine x. Very, very easy. So it means that wherever we see x in the general solution, we plug in x. Wherever we see y in the general solution, we plug in 0. And wherever we see u, we plug in what? Sine x. So we are going to have u. Our u is sine x. So we have sine x is equal to, our y is 0. So we have 0 plus a function of what? X. X is still x. And then we have g exponent negative y. Y is 0. So we have 0 here. So when we plug in the initial condition, this is what we are going to get. So we are going to have sine x is equal to a function of what? X. This is going to give us 1. Very, very easy. So at this very point, what we are going to do is that we are going to let any variable at all to represent what is in the function. So we'll let p be equal to what? X. So it means that wherever we see x in, or at this very point, we are going to replace it with p. Wherever we see x, we plug in what? P. Wherever we see p, we can plug in x. So we have sine, let's start with this. F at p is equal to sine of what? The angle p. Very, very easy. And then simple. So note this portion also. Once we have f of p is equal to sine p, we go back to the general solution. So these are general solution. And then we have f. Then we set for f. So this is the function f. It means that whatever is in the function here is the same as p. What is in the function here is the same as what? What is in f here. So in place of p, we are going to write f at x e exponent negative y. So we have f x e exponent negative y is equal to sine. This p is the same as this one here. So we have x e exponent negative y. Very, very easy. And then simple. So from here, we can say that wherever we see f at x e exponent negative y in the general solution, if you plug in this, wherever we see this in the general solution here, we are going to plug in this. So therefore, the particular solution becomes u at x comma y, then we have y plus a function of xe exponent negative y, which is the same as this, and this is the same as that. So we have sine xe exponent negative y, and this becomes our particular solution. Very, very easy and then simple. See you tomorrow. Bye bye. But if you haven't subscribed to my channel, please kind of hit on the subscribe button for me.